Welcome to Noob To Pro, a series where I teach you all the math concepts you need to know to become a math wizard. This episode is about LCM and it's episode 15. So, we will be learning a bunch of things this episode. First, we will be learning about LCM and a brand new method for finding HCF, which helps us find the LCM, and the correlation, which means what is the similar thing, what you can do with HCF and LCM. So first, what is LCM? We have already done this in the previous episodes, but we are doing a recap. LCM is the lowest common multiple for two numbers. So if we have two numbers, LCM will be the lowest multiple that is common between both of them. So for example, for 13 and 20, the LCM would be 260 because the lowest number, which is a multiple for both of these numbers, is 260. So now, what is the correlation? We need to know the correlation first before we learn the methods, because one of these new methods that we didn't learn earlier for HCF, it uses this correlation to find the LCM. So if we have two numbers, because these are any random numbers, that's why it's written x and y. These can be any numbers, so let's just say 5 and 10. So 5 times 10 is going to be equal to the HCF of 5 and 10 times the LCM of 5 and 10. This is always the case. No matter what numbers you have, if you multiply both of those numbers, it will be equal to the HCF of both numbers multiplied by the LCM of both numbers. And this is insanely important because the third method, first one is prime factorization, the other one is division, and the third one, it's the new one, and that one requires this correlation. So let's get started. We have to find the LCM of 90 and 135, and we have to use prime factorization. So if you remember in the previous episode, the prime factorization method works by finding the prime factors of both numbers and then you find HCF. But this is LCM. The method is slightly different. So first we are going to break them down into their prime factors. So 90, because it's ending in a 0, we know it's going to be divisible by 5. So let's put 5, and I'm going to put a times here. If we divide it by 5, we will be getting 18. And because it ends in an even number, we can just put 2 over here. That will give us 9. And 9 is just 3 times 3, so we can put 2 3s. And that is 90. So I'll just put 90 back. Now we have 135. So again, this ends in 5, so we can put a 5. Now, if we divide 135 by 5, that will give us 27. And now 27 is just 3 times 3 times 3. So we have already finished this number. So then we have 135. Now we have all this. And what we used to do for HCF was to just see what's common between these two and multiply those. But in this, it's a bit different. We will see what's common. We see that there are these 5s that are common. There's the 3 that's common. There's this 3 that's common. We only take what is common. And what we basically do is there are all these common ones. So let me just remove these circles. So there's a 5 that's common. So we will remove one of the 5s. Then there are 2 3s, and we'll just remove both of them, 2 3s. Actually, just for simplicity, I'm going to remove one from here and one from here. And now we are left with this mess. 5 times 2 times 3 times 3, blah, blah. So this is what we will be using. 5 times 2 times 3 times 3 times 3. So I'm just going to move this up here. 5 times 2 times 3 times 3 times 3. Let me just remove these is equal to's. So I'm just going to give us a quick recap of what I did. I'm going to go back. So this is what we have. So there are 2 5s that are common. These 2 5s. So we will remove one of them. Now these 2 3s are common. So we will remove one of them. And these 2 3s are common, so we remove one of them. Now on the in this number we are only left with 1 3, and we will just put that up here. And that's how we got this 5 times 2 times 3 thing. So now we will solve this. 5 times 2 is just 10. We know that 3 times 3 times 3 times 3 times is just 27, and 10 times 27 is just adding a 0 to 27, so 270. And this is our answer. So the LCM of 90 and 135 is equal to this, 270. And this was the prime factorization method. Now we will be moving on to the division method. So the division method is what I recommend to use, but the new method is the fastest method, even faster than the prime factorization method if you're good at it. So this new method, I'll just tell you when we come to it. So we have 72 and 84, so I'm going to note them down over here. And this one, it's much easier. So first I can divide both of them by 2. So that will give us over here 36 and 42. We can divide them by 2 again and get 18 and 21. So I'm actually running out of space here, so I'm going to note the 2 are down up here. Now I'm going to move this 18 and 21 up. So 18 and 21. Now we can put a 3 because both these numbers are divisible by 3, and that will give us 6 and 7. So now we cannot divide these further, so we will stop over here. So now we are left with these numbers. If I remove all these lines and everything, 2, 2, 3, 6, 7, and all we have to do is multiply them. So let me just move these down. 2 times 2 times 3 times 6 times 7. So 2 times 2 is 4. 6 times 7 is 42. Then 3 times 42 will give us 128. Let me just check that again. 3 times 42, no, it will give us 126. And now 4 times this will give us 504. So the LCM of 72 and 84 is just equal to 504. This is the division method. It's much simpler because in the prime factorization method you have to cancel out the one of the common ones. In this one you don't have to do any cancelling, just multiply it. So this is the method I recommend. But in the test that will be coming out when we finish all the chapters for this season, then you'll have a time limit. So in that time limit you'll have to do it fast, and for that the Euclidian algorithm method is going to be used. This method, for example, we learned the prime numbers. If there's some insanely big prime number and you can't find any factors and you keep looking around for factors, it will take you a long time to realize it's prime. So that's where this Euclidean algorithm comes in, because you can use this with any number, and you can find the answer. So let's get started. The way this will work is we have a grid like this. Sorry, not like that, like this. The division grid. So we will put the bigger number over here and the smaller number over here. And as you can see, the question says HCF, not LCM. The reason is, remember how I said that we need to know that correlation? The correlation is used with the HCF of the numbers to find the LCM. This method cannot directly be used for finding LCM. It can only be used for HCF. But luckily, with HCF, you can find the LCM. So let's get started with this method. In this one, you don't need to note down any numbers, just this division. So we have 452 and 612. So we will be dividing these. And you can only divide it once. So we will put 452 over here and subtract. So first we have 2 minus 2, which is 0. Then we can borrow. 11 minus 5 is 6, and 5 minus 4 is 1. So we get 160. So now this 452, we move it over here. Sorry, not 456, 452. And this 160, we move it over here. So I will put the 160 over here, and now we can remove everything else, and we have a new question. Now we will repeat. For 160, you can multiply by 2 and get 320. Now this is where many people make a mistake. After they get the answer, they will put that over here, and then they make a mistake. So let me explain what this mistake is. 2 minus 0 is obviously 2, 5 minus 2 is 3, 4 minus 3 is 1. Now what people do, they put the 320 over here. It's not 320. It is this over here. It's not 320 which is supposed to go here. It is always this 160. Even though 320 is a multiple of it, you do not do that. So 160 is what we put over here. So let me put 160. There we go, 160. And this 132, it will go up here, 132. Now we can subtract 132 from this, because you cannot do more than that, and this will give you 0 minus 2. We borrow 8, 2, and that's it, 28. So now we will put 132 over here, and we will put 28. Where is it? We will put 28 over here. Now we can subtract from this. What can we subtract? We can subtract 112. That's what we can subtract. We can subtract 112 from this, which is the number times 4. So wait, let me just check. Yep, 112. So 2 minus 2 is 0, 3 minus 1 is 2, and 1 minus 1 is 0. So we get 20. So over here we will put the 28, and over here we will put 20. And now we get 20 and 28. From this we can subtract 20, and that will give us 8 over here. Where is this? It will give us 8. So this 20 will go here, and the 8 will go here. Now we can subtract from this 16. It will give us 4. So the 8 will go here, and the 4 will go here. And now this is the final step. From this you can subtract the full 8 and get an answer of 0. So what is the answer? Where is this HCF? Is it 8? No, it's this number 4 right here. The last number that comes up here is the answer. So 4 is our final answer. I know this sounds like it took a long time, but that's because I have to draw it here and explain. But this method is the fastest one and the best method. So the HCF of 612 and 452, by the way, this is the question from the previous HCF episode. It's just 4. You might remember this question, but now we will use that to find the LCM. So I'm going to go back to the correlation page. It stated that if we have two numbers, x and y, x times y will give you the HCF of x and y times the LCM of x and y. So what we can do over here is, if we have x multiplied by y multiplied by the HCF that we got, this not multiplied, divided by the HCF that we got. Let me just put the time symbol here. This is going to give us the LCM. That's what it says. So we have to do 612 times 452. That's the first step, and this might take a long time. I have to write it a little small. I hope you can see. So 452. So starting off with 2 times 2 is 4, 2 times 1 is 2, and 2 times 6 is 12. Then we put a 0. 5 times 2 is 10 with a 1 carry. 5 times 1 is 5 with the carry, so it becomes 6, and 5 times 6 is 30. Now we have 2 zeros. I'm writing it here. 4 times 2 is 8. 4 times 1 is 4, and 4 times 6 is just 24. Now we can add up these numbers. Over here we have 0, 0, 6, 0, 3. Let me just add this. to get 0, 0. Over here it's a 4 with a 1 carry, 5, 7, 2. Now add 1, 2 to 4. And now that will, I'm just going to write the answer up here. That's a 4, that's a 2, that's a 6, that's a 6, that's a 7, and that's a 2. So this is what when you multiply both these numbers, this is what you get. So now you might be wondering, what do we do? If you remember, we divide this by the HCF. So we will divide this by 4. So we will subtract 24 from this bit. And that I'm just going to note the answer down here. That's a 6. So 3. We bring the 6 down, that's 36. And we can subtract the full 36, and that's a 9. Now we bring the 6 down, 6, we can subtract 4 from it, so that's a 1, 2, and that's what we get left. But now we bring this 2 down, 22, we can subtract 20 from that, and that gives us a 2 remainder. So that will be a 5 over here, and then there's a 2, we bring this 4 down and subtract 24 from that, and that gives us 0. This is 6. So this is what we get left, 69,156, and this is our final answer. This is the LCM of 612 and 452. If we were to do the other methods, this would take us a very long time. But with this, if you do it properly, you can get the answer very, very fast. So now it's time for the questions in the test. First, you have to find the LCM of 135 and 565 using the prime factorization method. Then you have to find the LCM of 462 and 854 using the division method. Then you have to find the LCM of 215 and 123 using the Euclidian Algorithm method. So you know the drill. Comment your answers down below and I will give you the feedback. So now the next episode, episode 16, percentage. It comes out this Sunday, which is the 14th of September 2025. Thanks for watching.